I hope the announcement was correct. I didn't understand. Sorry for that. So, I work in a relatively large company. And this company releases quite a few web products and updates them all the time. And that's such a large code base. So surely you have to secure it. So that company employs quite a few security engineers. So people who, look at the code and try to make our product secure. And I work in such a team. So we do several things to secure our applications. First of all, we try to write hardened libraries and make our front-end developers, of which we're talking about thousands of developers, use them. Then we try to make sure that they're using only those secure APIs and not something that they have coded on their own. So we use, for example, a lot of static analysis or dynamic analysis of our code base. We also do security reviews. So some people look manually at the code and make sure before launch that it's not vulnerable. And finally, we also run our bug bounty program in case we actually missed some vulnerabilities. So we think about security from the very early stage of the application to even after the launch, right? So we try to protect our users using multiple means. And that surely means that our applications end up being secure, right? Well, unfortunately, this is not the case, and especially it's not the case for the cross-site scripting vulns. So this is the data from our vulnerability rewards program in last year. Half of the payments that we give our external researchers for finding bugs in our software is about web bugs in specific. And out of those web bugs, cross-site scripting remains the best rewarded, let's say, vulnerability type, right? So it still is a problem, not even for, say, a simple web applications, but even for applications written by companies that employ multiple people whose sole job is to protect those applications from bugs like this. And yeah, I imagine this is also the problem in our applications, and the data in other applications, and the data surely shows that as well. So this is, I believe, from HackerOne. Yes, this is from HackerOne. XSS is a top vulnerability type being reported and then rewarded by those respective companies. Also Mozilla, cross-site scripting, it's a top vulnerability. Now, surely there is a problem. Now, what is this problem in specific? First of all, I would like to narrow down the conversation a little bit, because I'm only talking about the one subset of XSS vulnerabilities, which is the DOM-based vulnerabilities, the ones, let's say, introduced on the client. And after looking at this data, after trying to reason about it, after trying to understand what is the landscape that we are talking about, we think we know why DOM XSS still happens, even if you try really hard to eliminate it. First of all, DOM-based cross-site scripting is very easy to introduce. And second of all, it is very hard to detect, especially when we are talking about complex code bases, large applications. Now, first, a little bit of refresher. If you don't know DOM-based cross-site scripting, it's essentially a property of your JavaScript code. So everything is there in the client, in the browser, and you have some flaw. Essentially, there's data that comes from the user, who can be the attacker. So this data is usually in some strings within your code base. And this data gets passed around to one of the functions that are called the DOM XSS sinks. And as soon as you have a chain like that, so data comes from the attacker-controlled source to the sink, that sink will cause your web application to, well, essentially execute JavaScript, right? So you have a remote code execution equivalent in JavaScript. And this is an example, right? So a location hash is something that the attacker can control. It's a very common source of DOM XSS payloads. And the inner HTML property of an element is the sink. And once this data gets connected, the full variable in this case, we have a DOM XSS. Now, I would say that DOM XSS is very, very easy to introduce in your web application. This is part of the problem, right? First of all, this is obvious. As soon as anything user-controlled gets passed to this inner HTML property of the element, then you very clearly you have like this textbook example of XSS, right? But so you could tell your developers, for example, well, maybe don't pass user data to inner HTML, and then the problem is solved, right? Maybe you want to grab your source code for inner HTML and make sure that you review every time something is passed to inner HTML, and then you have clearly solved DOM XSS, right? Well, not really, because it's not just inner HTML, right? There's a lot of other things, and in each of those things, user data should never have been passed to them unless it was properly, let's say, treated, sanitized, or escaped, however you want to call it. Now, is this even a feasible problem to solve? Like, can you teach your, say, developers to take special care when interacting with those sources? I would say it's not really a very easy task, and it is obvious mistakes will happen, even if you do some sort of, even grepping some automation around checking for those things. But there's also a second part of the problem, which is it's not just easy to introduce, which can be exemplified by the fact that probably the very first web application that you have ever written, as soon as it does any sort of user data interpolation, you probably have just written an XSS in your web application, right? The web is full of examples like that. But the second part of the problem is it is very hard to detect for security professionals even. And let's do a very short quiz, show of hands. Do you think this code snippet is introducing a DOM XSS? Like, raise your hand if you think it is. Yes, at least one person is paying attention. So yes, this is a very clear example of DOM XSS, of course. But what about this one? Like, is this one a DOM XSS? Yes, exactly. And this is actually the core of the problem. Maybe it isn't DOM XSS. You have to pay additional attention and do some additional analysis to figure that out, right? You need to know where the bar comes from. Now, what about this one? Is this one a DOM XSS? And here's where you're wrong. It depends what foo means. Because if foo, for example, is a script element, then surely inserting into the text body of a script element, you have an equivalent of eval, essentially, right? So yeah, this is also problematic. How about this one, then? Can you tell anything about this line of code in isolation? You have no idea, right? Because if buzz is user-controlled or buzz is somehow set to, say, inner HTML, then you have the original first problem. And obviously, these are just very simplified examples, but the problem I'm trying to show is that to find DOM XSS, you need to understand the entirety of the application. Every potential line of code can possibly be used in a chain of between a sources and a sink that introduces DOM XSS. So in order to make sure that you do not have DOM XSSs, you need to review all of it. Like, you can't just ignore parts of your code base. But that brings us to a question: how do we make it easier? How do we maybe even eliminate DOM XSS from the web platform? Can we even do it? And I would say that yes, we can do it. It won't be easy, but we already have a proposal in place, let's say. And solving this requires us to think about introducing an API that, first of all, reduces this attack surface, such that not every line in your code base is potentially introducing a DOM XSS, but only small parts of it should be, for example, reviewed or analyzed deeply, and you could completely ignore those other parts of the application. And second of all is also crucial, which is making security explicit. So the rules that you use, for example, for sanitizing the data or processing it somehow or filtering it, are parts of your application code. You have to write them, essentially, and then they could be reviewed, right? Such that no magic is happening. For example, you can't pretend that, well, this data is actually sanitized, because it's very apparent by just looking at the code base that some escaping, for example, is not being done. And the API that is designed around those principles is essentially what I wanted to talk to you about, and this is trusted types. So what's the main idea? The main idea is we take a look at all those things that I mentioned before, and we make them strongly typed. Before, in the DOM, all those DOM things, say, for example, in HTML, accepted strings. And the strings, the problem with strings is that you do not know where do they come from, right? You need to analyze this whole code base to make sure that they were not attacker controlled. Here, we shift this problem, we make an abstraction of this problem, and we are trying to address the DOM XSS through this abstraction. So first of all, we make sure that for example, inner HTML doesn't accept strings anymore. And instead, we could use objects to pass to inner HTML function. The fun part is that the DOM API already behaves like that for, well, years, since probably its inception. And you can see a code example of that. So for example, if you pass an object that happens to have a toString function to inner HTML, this toString function will get executed, and then the resulting string will be actually assigned to the inner HTML property. So we use this trick essentially, but we introduce those trusted objects, those special types of the objects that embed the security information with them. And those three objects depend on the context, because XSS is a very contextual problem, because you need to sanitize, for example, URLs, you need to sanitize HTML differently, and maybe you want to control what gets passed to, for example, to eval or the script bodies, right? So there's at least three contexts that we are talking about. So what we propose is that there will be three new types of the objects, the trusted HTML for inner HTML and, say, for example, iframe source doc, trusted script, which is something that you usually pass to, for example, eval, or that you make a script body from, and trusted script URL, which is fairly obvious. This is the URLs of the script that your application is loading. And once we have introduced those types, you can put all the security rules and all this meta data around those types. Let's see how. First of all, we can look at the situation of how a web application would behave if trusted types are not enforced, right? So there is a support in the browser for trusted types, but the application didn't opt into being secured by them. So what happens is, thanks to this trick that I showed earlier, that you can still use strings with the things, obviously, in this particular case, having an XSS. But you can also just as well use those trusted objects. So a trusted HTML instance can be passed to inner HTML, and it will be silently or implicitly unwrapped by the browser, and you will get whatever was stored in the instance of the object instead, right? So your application still works if you introduce the types to your DOM things. But you could also just as well start enforcing it to actually maybe get some protection. So the way you control trusted types is by integrating with the content security policy header. And there's something in the CSP lingo, it's called a directive, right? So you have a trusted types directive, and then there's some data. Ignore the data for now. But essentially what happens once your application uses this CSP header is that while it still accepts those typed objects, it stops accepting strings, right? So what happens is there will be a CSP violation sent to your reporting server, for example, but also you will simply get a type error in your application. And this is actually a pretty big property of trusted types, meaning that you can start treating security bugs in your program similarly to all other programming bugs. You can debug them using the same tools. You can, for example, set up a Chrome debugger and try to find out why does this error happen in my application. So this is how trusted types in practice get enforced in the browser. And thanks to being in or integrating with the CSP, we could also have a property that is called the report-only mode, right? So you can get warnings when strings get assigned to things that do not break your application, but you still get some visibility, and you can progressively migrate it to using only trusted types. But here, obviously, comes a very crucial question. Okay, so yeah, types, cool idea, but how do I actually create those types, right? This is where the secret sauce is. And the way you create types, stay with me for a second, is you create policies. So we added policies in your content security policy. So we have like 2 layers of policies. Now, what does it mean? First of all, you use the trustedtypes.createPolicy function. And each policy has, first of all, a name, more on that later, but then a set of functions. And those set of functions define the rules of converting a string into a given trusted type object. So in this particular case, I have created a policy that will run my custom sanitizer on the data, and only when the sanitizer says the data is okay, and I removed, for example, all whatever inline event handlers and whatnot, then you will get an instance of a trusted object, and this happens like this. So you have a reference to the sanitizing policy variable, you call its createHTML function, the sanitizer gets called, and whatever object gets returned from this policy has the sanitized data inside it, right? So the security rules are solely in the body of this policy in the first code example. And later on, of course, you can use this trusted HTML with the inner HTML function. And now, the crucial part, in your application, using this whitelist at the very bottom, you can simply say that in my application, I only accept trusted type policies of the given names. What that means is that only the code within those 2 policies has a capability of introducing DOM XSS to my application. Everything, the rest of the application code base cannot possibly create trusted types, so cannot possibly call the DOM things, and therefore cannot possibly have or cause DOM XSS. There's a couple of caveats. The talk is really short, so I will just ignore them. But feel free to talk to me afterwards or ask some questions. I can surely describe it in more details. Now, this becomes a problem, right? Because this approach means that you have to migrate all of your application, or at least all of the parts that use or write to DOM, to trusted types. And that's simply a large task. Now, can we do something to make it simpler to migrate? Yes, we can. First of all, there's a report-only policy. But second of all, we have created a concept that is called the default policy. So this is a policy that you can create on your own, and it will be implicitly called by the browser the moment you are actually still using strings with the syncs. So this is like this last best efforts to convert a string into a type. And obviously this policy better be secure, because this is probably where, at least in the beginning of the migration, most of the data will come through. But the logic here is arbitrary, right? So for example, you may decide, say for example in your development environment, that I only want to log what is happening, what is going through the default policy, and fix it as it goes, right? As I debug this problem. And yeah, you can also just whitelist the default policy in the content security policy header. There's also one other thing. We noticed that while a lot of vulnerabilities, DOM XSS vulnerabilities, are being exploited by using the JavaScript URIs payload, it just so happens that the web applications use URLs a lot. Who knew? And not a lot of applications are actually using JavaScript URIs in their code bases. At least the modern applications tend not to depend on them and use other means of, well, executing code when someone clicks on a link. So we decided to just get rid of the JavaScript URLs. And by default, if your browser wants to navigate to a JavaScript URL and you are trusted types compliant, so you have this content security policy header with trusted types, then a default policy will be called on the value of this JavaScript URL. And if the default policy, for example, doesn't exist or doesn't allow for creating trusted script objects, then nothing bad will happen. But this is also a very nice way of introducing some potential carving out of certain URLs from this policy. Like, for example, here I allow JavaScript void 0, which is harmless, but no other payload can actually execute. So This is present in the browsers now. This is in Chrome, hidden behind the flag, and we started using it in our applications, and the results are fairly optimistic. So how can you deploy trusted types in a web application? Well, first of all, you try to migrate the libraries that actually write to the DOM in your web application. That's not a lot of code. That usually is somewhere around where you have client-side templating libraries, maybe some HTML sanitization, sometimes dynamic script loading. Only a couple of places of the web application actually touch the DOM or process the data that later on reaches into the DOM. Most of the application code is actually business logic that has no need of writing to the DOM in practice. So first you migrate those individual libraries to that write to the DOM and add trusted types to them. Second of all, try to do some static analysis, more elaborate or less elaborate. In Google, for example, we compile our JavaScript, so this becomes very easy to ascertain. But you can also just as well use some grepping or some code linters to make sure that no one is calling in HTML, for example, with a string, right? So you know that to the best of your abilities, to the best of your knowledge, your application is trusted type compliant. And then you start checking that in the browser. So you add a report-only policy with some trusted types directive that star allows for any policy names to be created. And then you observe violations because maybe you missed something, and then you debug. And once you debug, you actually go to 2. So you have to migrate additional libraries a little bit. And then as it narrows down, the violations drop. And finally, what you end up with, you can start enforcing trusted types. And what is a very nice property of it? Meaning that maybe you have reviewed this application for security at, say, tomorrow. It will also be secure the next year. Because no matter what new code gets introduced to your web application, without changing your content security policy header, no one can add a new policy to your application. Therefore, no one can even have the capability of introducing DOM XSS. Let's see some demo. So, as I said, this is already implemented in the browsers. So this is a the Chrome Canary browser. And it's a very simple example application, right? So we have an input text field and some buttons that will use either DOM Purify, the HTML sanitizer, or just inner HTML something, right? So obviously, if I click inner HTML, there's an alert, right? Because this payload contains JavaScript, let's say. Let me zoom in it a little bit. Now, if I sanitize, obviously DOM Purify is very nice of removing the actual value, right? The sanitized. Oh, well, more on that later, actually. But essentially, what DOM Purify did is it removed this on error equals alert, and the data is safe to include into the DOM. Now, but that happens without the trusted types. Now, the problem we are facing is I want to ascertain that every time something writes a string into the DOM, DOM Purify will be called to sanitize it, because I really trust, say, Mario Heydrich to have written DOM Purify in a way that removes JavaScript. So let's start enforcing. This just reloads the page with the content security policy header. And the moment I call inner HTML, I get a type error, right? So in the console, I can see that inner HTML was used with a string. Let me zoom it out a little bit. So therefore, a vulnerability exploitation has just been prevented. But also my application kind of broke, so that's not ideal, right? Just to demonstrate, if I sanitize it, it's still OK. Now, why is it OK? Because I used DOM Purify with this special mode that we added a couple of months ago, which is called return trusted type. So DOM Purify uses its own policy to create trusted HTML values on the sanitized data. And this is exactly the property that we are using here. So as you can see, it does work with DOM Purify, let's say, out of the box. Now, if I try to install a default policy and try to call this inner HTML function, what happens is this callback gets called, And I can do any custom logic I want. In this particular case, I call DOM purify. So let's see that in action. Yes, the output is actually sanitizing every string data that is passed to inner HTML and similar things in my application. So I know for sure that as long as DOM purify is okay with regards to sanitizing for DOM XSS, I have no DOM XSS problems in this very simple application. But obviously, this is not, this is just a toy example, right? So let me show you something on our actual application. So contacts.google.com already has some JavaScript code that uses trusted types. And we can see that in action here, right? So I can see what policies were actually created in this application. Well, there's like 7 policies of various names. Let me zoom it in a little bit. And we think everything is correct. We spent a couple of months migrating all this code base to new HTML, and you could click around through the application. Everything seems to work, but one part. So if you take a look at try to edit something, edit some contacts, show more here, and try to use, it's in report only mode, right? So I'm not actually breaking any code. But once I try to do this, you can see that there's some report-only violations sent. And thankfully, trusted types is part of your program now. So you can debug it as your regular violations. So I can click through this and see what's going on. Yeah, it seems this function was actually causing the violation. Like here, I'm, I guess, creating a script and just assigning any string value to its source property. But I can immediately see that this is some part of the Google Maps API based on the address of the script. So I know that we have to now migrate the Google Maps API into trusted types, which is what we are actually doing behind the scenes later on. And of course, on top of all of this, you also have the content security policy reports being sent. In this particular case, you can see that, yeah, there was something on this page that violated the trusted types directive, which looks like this. There's quite a few names here, but it actually will get simpler later on. This is only the first stages. But you know that inner HTML was assigned this value, and this was the origin of the script that caused the violation, and line number and column number, whatnot. So trusted types are usable on real web applications just as well, and they seem to give really nice properties. With trusted types, you get very nice control over the policies. So first of all, you can control the policy creation. And again, only by creating a policy, you even have the possibility of introducing DOM XSS. And by default, you do not have that possibility. So you can control who gets to create the policy by just using the whitelist of the names. And of course, no duplicates are allowed by default in this whitelist, such that no one can just create the policy whose name was already allowed. But you can also control the policy usage, which is also a very nice property for JavaScript code especially, which means that even if you have a policy that's, let's say, insecure, you can lock it down to only certain parts of your application. And then you only know that only the parts of the code that actually have a reference to the variable representing the policy, only those parts can introduce DOM-based cross-site scripting. So we can lock it down in a ECMAScript module or inside some local function variable, so you can definitely narrow down which parts of your application can potentially be vulnerable, right? And by reviewing the code of the policies, you can realistically ascertain that your application is actually secure. So what are the benefits of this approach? First of all, it makes web applications secure by default. And you get tremendously reduced the attack surface and also review surface, essentially, because every data flow that potentially comes from attacker-controlled source and reaches the DOM sink now has to pass through the policy, because this is the only way you can reach a DOM sink. And that makes it very natural to limit access to creation of the policies and limit access to the policies in the first place. And it helps you restructure the application in a way that makes it super easy to review. And this is sort of natural to the developers, and this is what we see happening already in our code base. So it does isolate the security-sensitive code from the rest of the application and makes it very easy to spot it and review it for security. But also, looking at the offensive side, it makes it very easy of spotting it and reviewing it for bugs, which is cool. So you get this very nice properties that let you reduce the attack surface, which I believe is the main advantage of this and similar APIs. You can already start using the trusted types with, say, React. You just have to, well, recompile it, essentially changing one property. You can use it with DOM Purify. There's many other libraries that we are working on integrating. And this feature is implemented in Chromium. You have to use the enable Blink features for trusted DOM types. There's, W3C specification draft. So we are, working on getting this adopted as a web standard. There's a polyfill, there's documentation. So I think by now we have a chance of stopping DOM XSS as a vulnerability class completely. And our early results show that this approach actually works. So take a look at the repository on GitHub, find some bugs. Some of them that were reported by the bug hunters were really amazing. So do take a look. Start maybe using it in Chrome and see how it goes. Give us feedback. Maybe we can work on something. Maybe we can improve this API. But so far, it looks like for the first time since 18 years, we actually have a chance of fixing DOM XSS, which is nice. And this is the end of the presentation. I will happily take some questions.